Hello everyone, I'm Lavkush and I work with web platform team at Rippling. My team basically owns all the user experience and developer experience at Rippling. We build toolings and solution and focus on diagnostics and telemetry that helps improve the front-end ecosystem. We work closely with the design team and the other product teams to ensure that our web application meets the need of user and other stakeholder. And I am also available on Twitter and YouTube. You can find me there. Today I'll be talking about, or in fact, I'll be walking you through the journey of Rippling of how we build a scalable infra for internationalization. And when I say scale, what I mean is, what does scale mean at Rippling? So Rippling internally powers 30 different products. We have over 4,000 pages with millions of active users. We have our software solutions available for web, mobile, desktop application, and then we have some software solutions available as mobile extensions as well. We have services for emails and notifications and stuff. We have over 600 to 800 developers who are contributing to our code bases from across more than 6 time zones. And from international perspective, we are supporting right now 50 plus locales and 4 languages, and these numbers are going to grow much higher in near future. And currently in our application, we have over 500,000 strings. Yeah, and yet we went global. We went global last year. Until last year, we were limited to US market, but soon we realized that we have a huge potential customer spread across the globe, and soon we wanted to expand our horizons. And as of today, we are rolling our product to new countries every other month. So the requirement was to build an infra for that. But as soon as you realize you have a business that you can take global, there are certain things that you need to understand. So once you are ready to take your business global, for example, I have a product which is built for US, but I want to launch it for India, then I need to understand the Indian users, right? How they read their numbers, what are the date formats that they use, and things like those stuff like what time zone they are in. So it's important to gather those information, build that knowledge. And then comes the part where you start normalizing your code, content and design so that you can actually adapt to those changes, right? If I go ahead and change my language to Hindi, my website should be able to accommodate those changes and start displaying those strings in Hindi. Similarly, if I go ahead and change my locale to, let's say, ENIN, then all my date formats will start reflecting how Indians use, right? That is DDMMYY. But your application is built in US, or ideally would be hard coding it with MMDDYY format and things like that, right? And the next part comes is the localization, where you are actually adapting to such changes. And the last part is our translation, where we are actually translating the strings. Yeah. So once this requirement came, we dove head first into the depth of engineering blocks. I started studying different articles, watched different tutorials. But soon I realized all the solutions that are present out there were not truly complete. That means I cannot readily go ahead and start integrating and using it, right? So we chose to build an in-house solution. And for that, we had to handpick some of the libraries. And then we built our own solution on top of that. First thing was to choose a translation framework. And we went ahead and we wrote our own library. It's called Live18n. And this library is internally powered by React i89 Next. Now, why we chose that library? So we did comparisons on various grounds, actually. Things like what are the basic requirements for a translation, right? For support of interpolations, right? In strings, there could be variables which you want to inject. Then support for pluralization, right? You don't want to have multiple copies of the same string, like this is a singular form, this is a plural form. And similarly, you also want to put some context. So those are the basic requirements of a translations. So that was the one comparison ground where we did. Then comes what are the resource loading strategies that you want to have, your fallback mechanisms, and things like obviously communities, how good the community support is. Based on these grounds, we chose React i89 as our translation library. But that's just the one part, right? There are multiple other things that you need to take care of. For example, date time formatting, how you format your currencies and numbers, because this is really important. These are really important. When I was researching, I just found out that we as an Indian use decimal as a decimal system, and for grouping we use commas to read our hundreds, thousands and stuff. But when you actually switch to German, it actually gets uh, swapped, where actually the commas become their decimals, and decimal becomes the grouping number. So it's very important that you put uh, those things into place correctly. And then obviously different formatting for numbers and stuff based on the reason code. So these are some of the important specs, and we went ahead and we kind of wrote our own utils on top of local codes to build such things. And for most of them, JavaScript INTL API is our base, which is ever evolving and very good. You must explore that. Okay, so once we had that solution, I actually wanted to highlight some of the challenges that we faced while building this solution. So I picked some of them, and then I want to walk you through them. These were like some of problems: seamless integration, performance optimization, string reusability, developer experience, and one interesting problem, which is at last, which affected our TypeScript compilation. So I want to talk about that. Okay, why seamless integration is a challenge? Why it was a challenge for us, right? So we were not bootstrapping a new project, or had to build a solution for a small scale application. We had a live product which has huge traffic with millions of active users. We cannot afford any disruption with user experience. And then our solution should also work for different platforms like web, mobile, browser extension and stuff, right? And once we have this integration, we should also provide our developer ability to incrementally enable this service for their modules. We cannot say this is a one-time thing, you go ahead and enable it for all. No developer will do that. So we have to give them a mechanism where they can do this thing incrementally. And then obviously there should be some mechanism to track how many strings are externalized versus what they are still to externalize. And for also to check things like if the particular string is available in certain local or language or not. So if you put all these things, this becomes a challenge. And how did we solve this? So we wrote our service library 189 as a service, which you can install as an npm package, and which is highly configurable. Different projects can pass their configuration in terms of what languages needs to be supported, what should be the fallback language, how you want to load your resource and stuff like that. And once you have that, you can use the hooks and HOCs and utils from this library to incrementally enable internationalization in your modules. Similarly, we also offer some test locales which you can turn on and off to keep track the strings that has been externalized and not. We also have something like config synchronization. So let's understand this. So at Tripling, we have like 30 different products, and we also have a design system library, which all these products uses for all our core components. And this library should also support the internationalization, which again in turn uses our library called library i89. So we mark it as a peer dependency, so that whenever the host project is installing it, whatever configuration that it is using for initialization gets respected in any of the direct dependency libraries. In our case, the design system. So this has worked really well for us, and some of the observation that we have made as of today, we have over 10,000 commits post we enabled this. We have over 35 plus module which is using the service for externalizing their strings. We have 6 software using this library, and we have seen 0 downtime as of now. That brings me to the second challenge, which is around the performance. When you are building your solution, this should be given utmost care. You cannot have a solution which is not performing. So we wanted to enable i89 and then without taking any performance hit, right? So the first thing is your time to first print should be very minimal, right? It should offer tree shaking, like we should be only bundling things which are actually getting used. Caching to definitely offer faster resource loading, and then efficient bundling. So when I was exploring, I found that most of the solutions that I found was preloading the resources, which actually doesn't care much about the initial bundle size, and that results in a slower first loading. So we also had to take care of this. We don't wanted to give this work to the developers like they do it on. So we have to take care of like when to load and what to load. We have around 20 MB of a string as of now, and it becomes really important like when you are loading what resource, such that your bundles are not getting affected. That's another thing. And then fallback loading. So this translation thing is incremental, right? Let's say today you are launching for English and tomorrow you are launching for Hindi, then it's quite possible that you don't have all the strings in place. And for the strings which are not there, you might want to fall back to a language, for example, English. So I cannot say that I'll preload all the resource even for Hindi, English, if that's my fallback language. Even that has to be loaded efficiently. So these were some of the challenges on the performance ground and how we did the solution for that. We made our library smart. What did we do to make it smart, right? So first thing which I want to pay attention was to loading the resource on demand and only loaded what's needed. Let's try to understand that with an example. So let's say I have like few different components which are requesting for a resource. Then first the request goes to my library, where library checks for this resource in a cache. If it is there, it will revert back with the resource, where then library will extract the translated string and give it back. But if it's not, then it makes a network request. And there is an interceptor that sits in between, which also optimizes for concurrent requests. So let's say you loaded two different components at the same time, which is requesting the same resource. It's quite possible because we often try to write reusable components, and then same can use a request for the same resource, right? So what this interceptor do is, if there is any request which is already in progress, it will just subscribe to that rather than making a new request, which helps us achieve this goal where we are making only single request per resource. Yeah, and once if it's any request, again we fetch all our resources from CDN. Having CDN is very important here because you'll be serving these static files from the edge locations, so that you fetch it very early. Now, once it is there, we update our cache and then again revert back with the resources. One thing is to note here, like whenever we are making request, we make two requests. One is for the actual resource and one is for the fallback. And while updating a resource, we also take care that we are only updating the cache only if the main language was not present, then we update with the fallback. So this solution again worked very well for us, and what we observed that we had a gain of over 4 MB in bundle size, which was like across the chunks. And then for the main bundle, we had a gain of around 100 KB. We reduced the network call to just one per resource, and we seen a 0 increase in latency for our first print. And that brings me to the next challenge, which is string reusability. This doesn't sound like a challenge, but why I'm calling it a challenge. Now, as I said, Rippling has over 30 different products, right? So let's say I'm building a page for web. Let's say I'm building a page for payroll on web, and then I'm building a same page in mobile. It's highly likely that I'll be using a lot of strings in same string in both these places, right? So I will want to reuse them. But how do I share these strings across the platforms? That becomes a challenge, right? At the same place, we also want to enforce some best practices when we are authoring these strings. For example, at Rippling, we use ICU messages formatting for all these translation strings. These are basically rules around how you define your plurals, something like you put some _1 for single one, for multiples you can put _ others and those stuff. We also want to, let's say, ban some, restrict some a special character that you shouldn't use this as a delimiter in your string. So if you want to put any restrictions or enforce any best practices around those strings, how will you do if they are spread across different repositories, right? That becomes a challenge. Similarly, you want to track how many languages you are supporting and stuff. And for these translations also, we use external services we call it like TMS platforms, translation management platforms, where the actual translation happens. Someone is sitting using machine translation to do that translation, or human vendors who are actually doing the translation. So if you are having duplicate strings, your cost will also go up. So you need to minimize that as well. And if you have also strings which are spread across the modules, then obviously you'll need to onboard your vendors to different repositories, which becomes challenging. You'll have to provide access to different repositories, which is also not good from a security point of view, because your actual code resides in these repositories. So if you see, this all becomes a challenge. And how we got around this was we went ahead with the approach where we have all our strings stored in a single repository, which helps us enforce any rules, best practices. In terms of ESLint rule, I can go ahead and write my own custom ESLint rule. I can enforce in the pipeline and stuff. And then we had to just give access to a single repository to our third-party vendors. We are using Phase for that purpose. So that helps us to minimize any duplication, string duplication. Let's look at a flow, how this flow works. So whenever our developer is making an APR to our translation repository, our TMS platform is actually monitoring a particular directive for a change. Whenever there is a change, these changes are pulled into the TMS platform where actual machine translation happens. Some translator will translate the string, and they'll give back merge PR, which is again merged to our code base, and then where some pipeline runs for code quality check. Once it is merged to the master, then we again run a release pipeline, which uploads all our resources to CDN. We are using Cloudflare here. And once it is uploaded to CDN, different products can go ahead and fetch whatever is needed and then bundle with their own application. Some stats around strings. We have like over 5,000 strings currently in our application, which are distributed across 85 namespaces. Namespaces are basically logical grouping of these strings. And then we have currently launched 4 languages, and there are like much more to be launched in near future. Yeah. Whenever you are authoring any framework, it becomes very important that you should also worry about the developer experience. Whatever the developer, if it should be easy to use, and then it should also provide some clear and actionable feedback to the developer whenever he is using the platform. If you are making any mistake, how do you notify your users that this is not the right way of using my framework or something like that? At the same point, it should be testable. Your whole framework as well as the components which are using your framework should be testable. Our goal was to kind of get a framework where we had already a lot of tests in place, and we wanted to have zero migration for those tests even after enabling this framework. So when we enabled this framework, all our English strings were removed from our code base, and they were moved to a different repository. So obviously there was now developer has to replace those English string with some keys, but we took care of those conditions where they don't have to do those migrations, and thus testability becomes an important factor. Similarly, customization is another flexibility that we have to provide in our terms, where which should be the fallback language, what strategy to load resources and stuff. They can vary from product to product, right? And developer should be given that freedom that how they want to use your framework. Some IntelliSense, for example, in my case, we wanted to give IntelliSense for all the keys that could be possible under one namespace. So TypeScript helps there. So these are the few developer experience that we thought of. And the way we take care of is like giving clear and concise feedback. So first, look at the flow when developers is doing development on his local machine, right? The very first thing is like he is powered with the TypeScript IntelliSense, where he get all those good IntelliSense, what keys he can use, what are the possible namespaces and stuff. And if there is some error on local environment, we give them a snack bar alert that, okay, this is a using and this is not a right way to use it. And then we also break pages on local if there is no translation present for that. If somehow it manages to reach to our GitHub, again, the pipeline runs where in test we'll break the pages, we'll send back Slack alerts and for those things. And on production, we do a bit of a graceful handling where if the translation is not present, we'll replace it either with a default fallback string or empty string. and then for the same Slack notification will be sent, and then we'll also log Sentry, where developer can go and check for their product, like how many errors has been logged for his particular module. That's from alerting. And from customization point of view, whatever the mechanism that you're seeing on the left hand side, that are actually configured via the configuration, like how you want it to behave on your local machine, CI and stuff. Okay, so when we enabled this TypeScript for intelligence thing, initially it was fine, but as we kept on adding more and more string, our TypeScript compilation took a hit. The reason behind this was because we support nested JSON as well. So just to replicate whatever structure that you are following in code, you can put similar structure in your JSON for all those strings. And TypeScript generates all these possibilities in memory, like what are the possible keys for that namespace. And as the number grew, it started taking a hit. The TypeScript compilation rose from 5 minutes to 30 minutes, and there was a point where it started throwing error a heap out of memory, and it was no longer working at all. We raised this with the library, the original library React i89 next, and they said it's a work in progress, and they will come back with solution in upcoming versions. But we couldn't afford that. We had to have our solution in place. We have over 600 developers which are actively using it, so we could not afford not having this. So how we got around this? Yeah. So we architected or rethought those types, and we wrote our own types on top of that, and we overrided that. But how is that solving? So what we did is, whatever the possibilities of those keys were there, we pre-generated those on our end, and then we gave it back to the library. So there was now nothing going on the fly. So we had a script in place which all pre-generates all these possibilities, and then we give it back to the library. So now you can see how smooth our intelligence is working. So this actually helps us again take our compilation time back to normal, and the intelligence was very great. So now it is giving intelligence for more than 1,000 keys and stuff, and which was really helpful. So yeah, that brings me to the end of this session. If you guys have any query.